Alright, welcome to the 8th part of our forces unit. What we're actually going to do today is we're not going to learn anything new, we're just going to look at a more complex problem and summarize what we have covered so far, which includes the applied force. We've talked a little bit about friction, we're going to do more on that after this video. We've talked about Fg, the normal force, elastic force, and tension force. All of these things we've talked about, we've learned about them, so you can see them in problems. Complex problems are going to combine all of these ideas together, and so here's an example. So we've got two blocks hanging over a pulley. The rope, as always, is massless, and so is the pulley, and it's resistance free, no friction. And we've got one is 5 kilograms, the other is 3 kilograms. They're initially at rest. Now, logically, when we have two things that are not the same weight, as soon as we let go, the heavier one's going to be pulled to the ground and the other one's going to be lifted up. That's how this works. So, we need to figure out the tension in the rope and the acceleration of the blocks. So we've got our free body diagrams of each one. Now, as tension would say, the tension in the rope has to be the same on all ends of it, so the tension pulling up on both blocks is the same, so it's Ft, and then we've got Fg2 and Fg1 for each block. Now, one thing that we have to do is our Fnet for each one, so we're going to start with Fnet on 1 is going to be Ft plus Fg1, and then Fnet 2, that's the wrong place for the 2. Fnet 2 is just going to be almost the same, Ft plus Fg2. So, now we have to apply the directions. This is where this problem gets a little more complicated. On this rope, so if we follow this rope all the way around here, if this side goes down, this side goes up. So if we say that down on this side is positive because it's going to move that way, then this side has to be up positive. So on each free body diagram it will actually be different. So for the first mass, the heavier one, we would have Fnet, so Ma is going to be, this time, negative Ft plus Fg1. For the second mass, the lighter one, the one that's going to be moving up, we're going to get Ma is equal to Ft as positive minus Fg2. So there's a slight difference in there, but it is very, very important. Now, what we do with this from here is very purposeful to what we're going to try and find. If you want to find the acceleration, you're going to solve one of the equations for the acceleration, and for the tension force, put it in there, and we'll get rid of that. Or if you want to find the tension, we have to solve an equation for the acceleration and combine them. Mathematically, it's easier to actually get the acceleration first, so that's what we're going to do. To do that, I'm going to make one of my equations equal to Ft, so I'm actually going to do it to the second one, because Ft is already positive, and so I just move Fg over, and then I get this equation. And I'm going to take that, and I'm going to put it in right here. So I get M1A is equal to minus M2A plus Fg2 plus Fg1. Now we just have to isolate and rearrange for acceleration. We have to do a little bit of, algebra math here. So carry that negative through. Now we're going to also get rid of our Fg2, and because we know that that's mg of mass 2 and m1 there. We want to get the acceleration onto the same side so that we can isolate it. So we have m1a plus m2a is equal to minus m2g plus m1g. A little bit of factoring. And we get an equation here of minus m2g plus m1g all over m1 plus m2. Plug in your numbers and you will get 2.4 meters per second squared. So that is actually our answer for B. But now we want to find out the tension. Now the easiest place to do that is from our equation 1, because we know that Ft is equal to Fg2 plus m2a. And we just figured out what A is, so now we can just plug everything in and calculate it fairly easily, which we'll calculate to, with sig figs, 36 newtons. So the trick to this problem is knowing the directions when you're trying to figure out your FNet equations. If you reverse them, you would not get the right answers. And always, 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 if you're on a rope, the directions have to be consistent. Along the rope. So that's very, very important. We'll have some time to go through a lot more problems in class, and hopefully these are starting to make some sense. And as always, physics is awesome.